Before viewing video lessons, it is important to read the textbook using the learning guide as your turn-by-turn directions. Then use the learning guide to take organized notes in your own words with examples and pictures. This video continues Human Memory, Chapter 7. In this video, we're going to begin to focus on retrieval and forgetting in memory. So in the previous videos, we talked about three key processes in memory: input, encoding, storage, and retrieval. We've gone through in depth the process of input, encoding, and storage. And now we're going to focus on retrieval. So with retrieval, we're going to be able to recover a complete and accurate memory code when we need it. So the goal for retrieval is to find the complete and accurate memory exactly when I want it. So in order to understand how retrieval works, we're going to look at how it's organized because that impacts retrieval. So in a previous video, we talked about how knowledge is represented and organized in semantic networks, or networks of connection between pieces of information. And connectionist theories are going to look at how these networks influence our retrieval. Connectionist theories say that we retrieve memories by spreading activation in schemas that are organized in semantic networks. A schema is an organized cluster of knowledge about a particular object or event based on your previous experience. So if you pull up your knowledge about a particular object or event, it's going to be clustered with other similar types of experiences. So for example, if you think about a stapler, you're going to pull up a cluster of knowledge about staplers in general. You may think of staplers of all different sizes, those itty-bitty teeny tiny ones you can put in your bag and carry around to classes, all the way up to those big industrial models that you may have seen in a library or a copy shop, for example. And you know stuff about staplers. So you may know things like typically when you press down on the top with enough force, a little metal object pops out called a staple, and that typically those are used to join pieces of paper together. That would be your schema for staplers. Now your schema is based on your previous experience. My schema, while it may be similar, could be different. So for example, my schema for staplers includes a lot of that stuff, but it also includes the fact that, those things are useless. They have never worked, they jam, they're out of staples. The only thing they're good for is throwing it across the room when you're frustrated. So if that's my schema, it's because I've had previous experiences that have informed that. Now, every schema is going to be embedded in a semantic network. So schemas are connected to one another. So the color red here is directly connected to its schema. Those are the things that red is directly connected to. But red is also a part of a greater semantic network, which is everything that red is connected to is also connected to other things. So when we retrieve a memory, when we think and remember, it's because of activation in these interconnected networks. So here is our previous example of a semantic network related to Zergaba. And I think I pronounced it wrong. Zergab. All right. So in order to retrieve this memory, I can activate the semantic network and travel down these pathways to get it. But in order to do that, I need something called a cue. So a retrieval cue is some sort of stimuli that activates this semantic network. It's a sight, a sound, a smell, a taste, a touch that sets off activation in this network and allows me to get to the target memory. So we're going to use the example of a college student taking a test to help understand how retrieval cues can impact our memory retrieval. So sometimes in a class, you're given a recognition task to help assess your learning. A recognition task has lots of cues. In fact, it has the correct information in the cue itself. So for example, if you were given a textbook definition for a term and asked to choose from 4 options, multiple choice, A, B, C, D, which term matched that textbook definition, that would be a recognition task. Now, in many college classes, to include this one, you're not going to get those types of test questions. What you're going to get is a recall task with fewer cues. When you have fewer cues, then you really have to work hard to find the right answer in your memory and then recognize that it is the one that matches the stimuli. So for example, in this class, a lot of our quiz and exam questions are what we call application multiple choice questions. That's when you are given an example or a scenario or alternate wording, and you're asked to identify the correct concept or term that goes with that particular application. You may also, in some of your classes, have short answer or essay questions. Those are also recall tasks. Now, you've probably recognized for yourself that typically recognition tasks that give you lots and lots of cues are much easier than recall tasks where there are fewer cues. Now, one thing you may do on the test when you're trying to find a memory is you may use something called context cues. Now, this is where you can put yourself in a similar situation in which that memory was formed. Now, outside of a testing environment, this is when you lost your keys and you physically go back to the last point in time in which you remember having those keys in your hand. That would be a context cue. Now, for testing, what you may sometimes do is, in your mind, reimagine the context in which you were learning that material. So you may think about this moment right now. Where were you when you watched this video? What was going on? You may think, okay, I'm at the kitchen table, I remember I got distracted for a little bit because the dog came in, but then they left and I refocused and I remember, oh yeah, there was a picture of dog on the screen and that was like related to the dog coming in, and so I'm going to use that. So you're going to try to basically activate the far reaches of the semantic network to try to get to that answer. Now, another thing that can sometimes help in retrieval is something called encoding specificity. This is where you want to encode those memories so that they most closely match the retrieval cues. So, if you're taking a class that only tests you on textbook definitions and multiple choice or matching ways, then only study that way. But if you're taking a class like this one that tests you with recall, you're going to want to study through application and writing things in your own words and thinking of your own examples and pictures, because that's going to match your retrieval cues much more closely. So let's look at an example of where this maybe didn't go so well. So here we have few retrieval cues. We're going to have an exam question where there's not much in there that is textbook definition, coupled with poor encoding. So I'm trying to get to the correct answer, right? But if I haven't encoded it well, I'm not going to get to the correct answer. So poorly encoded information is information that has no meaning. There's no definition that makes sense to you stored in your memory. You have no examples that you can draw on, and you don't have any pictures or dual codes to help you make sense of what's going on. In short, poorly encoded information has no connections, and without connections, you cannot retrieve. So let's look at how that same question would look if you had a well-encoded, deep semantic enriched encoding. So here we have our exam question, same question as before. And what we find is that if we've built this really rich code, we have multiple pathways we can travel to get to that correct answer. And we can also use that reinstating the context to help sort of prime and activate our memory. When you do this, you have a deeply encoded memory that you have a network that can activate to help get you to that correct answer. So, when you pay attention to the stimuli, when you encode it well, it's learned and you create a retrievable memory code. As long as you don't forget. And so what we'll look at in our next video are problems in that retrieval process and where forgetting comes in.